So the last video there finished up with this question here. You had a circle passing through the points 1, 1, 2, minus 1, whose center was on the line 3x minus y equals 7. Just as regards sketching the line here, its slope is minus a over b. So there's, it's minus a over b. So the slope m is equal to 3. And then just pick a, now the reason I didn't use the intercept method here where I let x equals 0, it's fine, I get y equals minus 7. But when I let y equals 0, well, that actually do the job actually there, because you get y equals minus 7, which is a bit far down though. I just sometimes just use a random value for x. For example, 3 times 3 is 9. What minus what will give me 7? 9 minus 2 will give me 7. So I have the point then 3, 2. So I go and plot whatever, 3, 2, and then slope is 3, so I come out 1 and up 3, draw a dot there, and then draw my line. Something along that lines there now. Pardon the pun, maybe. Now for this one here, as I said before, rely on your general equation if you want. Just go with this one every single time. And you do the usual crack here. We actually find the equation of this line here. And that line will, because that's a tangent point of contact, perpendicular line will pass through the center. So you go and you find that line, and then go and sub your minus g minus f in for that, and sub 4, 1 and 6 minus 5 into the general equation as well. You end up with 3 equations. Go and work them out. In this case here, though, I think it's easier if you notice that we have 2 points on the circle. So if I found the midpoint of that, and I found the perpendicular slope of that line, I would then have a line that also passes through the center, because the perpendicular bisector of the chord passes through the center, and then do simultaneous equations to find the center. That would be the road I would go down there. But again, like I say, stick with the general equation if you prefer. That can be your go-to guy in these situations. In this example, we're forced to use the general equation. So again, this is important you understand this. If a circle touches, for example, the x-axis, the y value of the center, the absolute value of that, is equal to the radius, because sometimes the y value, of course, can be negative, and r is a distance, so it has to be positive. Now, what impact does that have? Well, we have the formula r equals the square root of g squared plus f squared minus c. That's equal to, if it's touching the x-axis, the modulus of minus f, or the absolute value of minus f. So you square both sides and you end up with g squared being equal to c. Then you can change this equation here, because g squared equals c. The equation becomes like this. And I sub in my 2 points, and I get this equation and this equation. Now, if I can eliminate f, I will be left with just an equation with g in it, and that's what happens there. You eliminate f, and you get a g squared here, and there's 2, obviously, circles that satisfy this. And you go on down there and do the simultaneous, solve the quadratic, get your values for g, get your values for f, and then you're ready to fill in the answer. Nice enough, I think. And I went to this in class the last day. Again, radius is 5, root 5, sorry. So get out your formula, write it down this here, square both sides. That's one equation. And then you've got the 2 points, which you sub into the general equation of a circle. And you get these here. And just happens to be 2f plus c here. So if you subtract the 2 equations away from each other, you end up with g being equal to 1, which makes that kind of nice. And you go on down along here again, and you end up with 2 equations again, because you end up with a quadratic with f in it. That needs practice, that one. For me now, I would 100% be going with drawing a sketch beforehand to see if there's any easier way of doing it. And there actually was in that case, which I went through in class. Ask me if you need to have a look through this one as well, guys. It's tricky enough. Well, the marking scheme, sorry, is a bit confusing. It isn't that clearly done. If you don't get it, if you want me to do it a little bit clearer, ask me anytime. It's no problem. And then I just took last year's, again, I just did an alternative solution there down here on the page. Have a read through it. Again, if you're not happy about the way it's done there and you want to redone again, I'll do it out for you, no problem at all. Okay, I'm going to leave it there now.